So this is Dr. Kavita Singh, Associate Professor in Department of Civil Engineering, in Institute of Aeronautical Engineering. So today our topic will be for discussion about components of GIS. So till now in the previous lectures we have discussed about ArcGIS, about different types of data like spatial data, non-spatial data, what is GIS. So to work with this all kinds of data, to work with ArcGIS, we should know what are the components of GIS. Components means how does a GIS setup runs. So what are the things which are required to run a GIS setup. So that all we are going to discuss today. So in components you may have different types of hardware, software, users, people and data and all. That all we are going to learn today in this topic, that is components of GIS. So let us start with the contents. So today's contents are main components of GIS, major components of GIS, hardware, software, data, people, procedure, network. So these are all different types of we can say components which are, if we combine together, then together we call it as components of GIS. Okay. So let us start with the main components of GIS. So there are two things, main components and major components. So what are the main components? First let us understand. So Geographic Information System has three main components, namely computer system, that is hardware, sets of application software modules, and geospatial data users. So these all comes under the main components of GIS. So these are the three things which we mainly talk about when we talk about GIS. The main components will be computer system. So computer system can include hardware, software, modules and geospatial data as well as users. So later we can just in detail we can understand what are the major components out of this main components. So GIS run on the whole spectrum of computer system, ranges from portable personal computers to multi-user supercomputers and are programmed in a wide variety of software packages. Okay. So this is how it looks like, the components of GIS. When we talk about computer system, so computer system is about hardware, software and capture, storage. So these are all processing, analysis, display and all comes under computer system. So next, when you talk about geospatial data, so in the previous lecture, so many times we have discussed about spatial and non-spatial. So what is geospatial data? Geospatial data is spatial and non-spatial data. When it is studied together, then it is called as geospatial data. So under geospatial data, we have maps, aerial photographs, satellite images, statistics tables, etc. Same thing when you talk about users. So in users we have design of standards, we have updating, analysis and implementations. That all comes under the user part. So we have the three main components here. One is computer system, the other one is data, and the third thing is users. So these are the three main components. When you want to run a GIS setup, these three components are required to run together. Then only a GIS is complete. So without computer system, we cannot run the GIS system. With users, we cannot run the GIS system. With geospatial data, we cannot run the GIS system. So these three main components we have to run together. We have to gather together. Then only we can run the GIS process. Okay. So if we talk about the hardware components, so in hardware we have CPU, tape drive, disk, and you have a computer system, you have a printer, you have a scanner, you have a plotter. So these are all the hardware components of GIS. So in all the cases, there are a number of elements that are essential for effective GIS operations. So these includes the presence of, to operate a GIS, these includes presence of processor. First thing, when you talk about hardware, we need a processor with sufficient power to run the software. So if you have a hardware system, if you have a hardware setup, you need a processor which should have a sufficient power, then only you can run the software. So these are the important things which we need to run the GIS software. Sufficient memory for the storage of large volumes of data, and a good quality high resolution color graphics screen we should have. Data input output devices like digitizers, scanners, keyboards, printer, plotters. These all should be included to run a GIS setup. Now, when you talk about the major components of GIS, so the major components of GIS, so before we have seen the main components. So under the main components, we are having the major components that we have: hardware, software, data, people, procedure, and network. So these are all the major components. Along with these components, the GIS setup will run. So 6 parts of GIS are hardware, software, data, people, procedure, and network. So just now we have discussed about hardware in the previous slide. So the hardware is the computer central processing unit, is a general hardware component of GIS, and it is attached to the disk drive storage unit used for storing data and program. So devices like digitizers, scanners are used for converting the data which are available in the form of maps and documents into digital form and send them to the computer system. So hardware is like connection of different types of hardware system, like it should have a digitizer, it should have a scanner, it should have a plotter, it should have a printer, which should be connected to a GIS setup, so that whenever you want to use the data, first of all, if you have the digitizer, so we can digitize it to the digitizer. If you have a scanner, we can scan in that scanner system. A plotter should be there. So these all things are important when you go with this GIS setup. So display device or a plotter is used, which presents the result of the data processing. Now a tape device is used to store the data for the program and magnetic tape. So when I was talking about the plotter, so this is how the plotter looks like, and these are the different we can say magnetic tape or devices where we can store the data. So this is the plotter or scanner where you can scan the big size map, like A0 size map. If you want to scan, that should be connected to the computer system. And from this computer system, any A0 size map will be easily scanned. So we can scan this map, and you can just use the analog data, and you can convert through this plotter to a digital data. Okay, digital data, or we can say raster data, right? So this raster data can be used in your computer system. You can just see this is the map which is in the form of analog in the paper format, or we can say as a paper format. So this paper format map, when it is scanned, this can be viewed in the computer system. So same map is viewed in the computer system. So this is how the hardware works in a GIS setup. Now when you talk about software, so we should have different types of software to organize the data, to store the data, to manipulate the data, to analysis the data. So this all data, if you want to do the manipulation and analysis, and if you want to get a proper output, we have to use the software. So the GIS software includes the program and the user's interface for driving the hardware. So GIS software is essential to generate, store, analyze, manipulate, and display geographic information or data. So it's a GIS software when we have studied in the previous lecture. So what is GIS? GIS is the setup of hardware and software which can generate, which can store, analyze, manipulate, and display the data. So a good GIS software requires user friendliness and functionalities, capabilities, compatibilities, updatability, documentation, cost effectiveness. This all should be available with the software. So the basic function GIS software should offer can be grouped into data capture, data management, data analysis, and data representation. Now when you talk about the data capture, so no data, no GIS. Data capture is no data, no GIS. That means what? No data and no GIS means without data, GIS is not possible. So without data, GIS is not at all possible, because data is only the thing which you can feed in GIS, and then only you can get the output. So what is the type of data we use? Data is used in GIS is spatial and non-spatial. Spatial and non-spatial. So these two type of data we can use in GIS, which can be helpful to us for creating your own creation or to create a different kinds of map and finally to get a proper output or a result out of it. So importing of digital data from a disk network or a database or digitizing it through the use of peripheral devices. Next thing is data management. Quality is essential. So one step beyond the data capture is data editing and maintenance. So editing involves functions such as editing, duplicating, deleting spatial attribute data as well as creation and management of metadata. So I hope you remember what is metadata. Metadata is data about the data, which it will give the description about the data. And data analysis asks questions like GIS is typically used to answer questions related to space. For the purpose of finding an answer, a GIS should not only offer tools to query and retrieve the data, but also functions for data integration and modeling. Next is visualization, make it visible. Any analysis of data is only useful if the final output is also understood by the intended recipient. So GIS offers the tools present data in the various ways, ranging from displaying a tabular information or over the graph, chart, or production to printing maps. So visualization of the data in the form of charts or in the form of, we can say in the form of a graph, we can just visualize the data and then only it is, we can see the data in the GIS processing. So GIS offers the tools to present the data in the various ways, ranging from the displaying tabular information over graph, chart, production to printing of maps. So aside from these basic functions, a GIS should also offer the ways of customizing and creating a new tools application according to your needs. So depending on the software, this can be either be done through well-known programming or scripting languages. So the following is a list of GIS software producers and their main products. Like we have different softwares. In the previous lectures we have discussed about the ArcGIS, which was the product of ISRI. So what is ISRI? That is Environmental System Research Institute. So which has developed these all softwares too. That is ArcInfo, ArcView and ArcGIS. So these softwares, it has been developed by the ISRI and these are helpful for creating the spatial and non-spatial data and to get a final output out of that. So we have Autodesk, AutoCAD Map, and International Institute of Aerospace. We have Survey and Earth Sciences, that is ILWIS. Then we have a Map Info Corporation, Map Info, PCI Geomatics, TA Map, and TeloGIS, that is GeoWIS. These are different softwares which we can use in GIS. Now coming to the next important component, major component of GIS, that is data. So the most important component of GIS is data. So we have hardware, we have software, but if you don't have data, you cannot work with GIS. So if you have a hardware and software, you have to see that you should have a sufficient data to get a proper output of it. So the most important component of GIS is the data. So geographic data and related tabular data can be collected in-house, compiled to the custom specifications and requirement. A GIS can integrate spatial data with other existing data resources often stored in a corporate DBMS. So what type of data we use in GIS? If you remember, we have discussed before also. So the GIS should have spatial data and non-spatial data. These two types of data should be available in GIS. So these are the spatial data in GIS. This is non-spatial data in GIS. So what type of spatial data we have here? We have a satellite. We should have aerial photo or a topo sheet. Topo sheet, that to scan. This type of data if we have, then only we can work with GIS. Along with the spatial, we should have the non-spatial GIS, non-spatial data. So what type of non-spatial data is this type of data? That should be in the form of tables, charts, or you can say graphs. So these all types of data is comes under non-spatial data. So the ability of GIS to handle and process geographically referenced data distinguish GIS from other information systems. So geographically referenced data describe both the location and characteristics of spatial feature on the Earth's surface. GIS is therefore involves two geographic data components. So that is two geographic components are spatial and non-spatial. So spatial data describes the absolute and relative location of geographic feature. It relates to the geometry of the spatial feature. And second thing is attribute data. Attribute data describes the characteristics of spatial features. Attribute data are often referred to as tabular data. So what is attribute data? So this is nothing but it is the other name of non-spatial. So non-spatial data is also known as attribute and it is also known as spatial. Okay. So there are different names for non-spatial data. So non-spatial data different names are attribute data, non-spatial data or spatial data. Okay. Next is like spatial data. If you see in the previous lectures also we have discussed about this point. So this is vector, this is real world and this is raster. So vector is like what is vector and what is raster? So raster is we can say that this is the clipped image or we can say photo image. And what is the vector? Vector is about this is the converting raster data to vector by using point, line and polygon. Okay. So these three features if we use, we can convert this entire raster data to vector. So raster data is representation of real world we can say. So this is the real world. If you want to represent this in the form of raster, so we have to just click the image, we have to just capture the image. So that will be represented in the form of grids. Okay. So each information will be represented in the form of grids. Suppose this is the real world, this is the line. So if you want to show in the raster, it will be represented as grids like that. Single grid pixels. Now same thing if you want to show in the vector form, so it will be represented in the form of line, point. Okay. So raster data type consists of rows and columns of cells with each cell storing a single value. This is the spatial data. So this is the real world. Okay. And from real world it is converted to vector and raster. So this is the raster. So from raster we can convert to vector. So this is two types of data. Now if we talk about the spatial data in vector, we have point entities, we have line entities, we have polygon entities. So what is point entity? Point defines discrete location of geographic feature, too small to depicted as lines or areas such as well location, telephone and pole, etc. So line features means we have to, when the image is captured, from the captured image, the information we have to categorize what are the features can be converted into point. So if you have a well location, if in the real world, this is the real world, if you have to show the well, so we will be showing in the form of points. So if you want to show the telephone pole, that also will be showing in the form of point. So this is how we represent the point features. Then let us come to line features, line entities. Line entities can be defined as all features built up of straight line segments made up of two or more coordinates. So this is like making a line feature of two or more coordinates. So it is a linear feature, continuous features. It will be like roads, railway tracks and all. Now area entities. So area of polygon can be represented in various ways in vector database. The simplest way to represent a polygon is an extension of simple chain. That is to represent each polygon as set of xy coordinates on the boundary. So areas are closed figures that represent shape and location of homogeneous features such as states, soil, types, land use and zones. So what is area? Basically area is polygon. Okay, if you remember point, line and polygon. So it is also known as area. Okay, so polygon is also known as area. Now attribute data is what? Attribute data is also known as non-spatial. So non-spatial data is also called as attribute data. So georelational data model links spatial data, attribute data by ID or attribute data stored. So it is given as a unique ID to each spatial data. Now attribute data stored in feature attribute table which contains the ID. So row is called a record, column is called a field or an item. So this is called as attribute data. Next, coming to the next major component, we talk about procedure and method. So what is the procedure and method? So we have to follow some procedure to run the GIS setup. So this is also comes under the major component of GIS. So procedure more related to the management aspect of GIS is referred to lines of reporting, control points and other mechanism of ensuring the high quality of GIS. So the procedure used to input the analyze and query the data, determine the quality and validity of the final product. So how to run the software, how to assign the points, how to add the spatial data, how to add the non-spatial data, or how to control the points, that all comes under the procedure and the method, how to analyze the data, query the data, and finally get the final product out of that. So the right method is to key for a successful operation of GIS technology. So the well-designed implementation plan and business rules are unique to each organization. Now, when you talk about this thing, procedure and method, after procedure and method, to use this procedure and method, people are required. So who are those people? So the users are the people who work on this kind of GIS software. So GIS technology is of limited value without the people who manage the system and develop plans for applying it to the real world problems. So if the people are not there, if they don't apply the real world problems by using the GIS software, by using the hardware and the software, then there is no use of GIS. So it is also a very important part of the GIS software, GIS components, that they should have a people to use this software or hardware. Okay, so GIS users range from technical specialists to who design and maintain the system. So to design a software, to design a hardware, people are required. So to run the component, first thing what? Hardware. Okay, so hardware is designed by the people. Okay, designed by the people. And second thing is like to maintain the system, people are required. That too, it should be a skilled person, it should be skilled people, those who are required to maintain the hardware and as well as the software, and those who use it and to help them perform their everyday work. So they should need a skilled person or skilled people to run the setup of GIS. Okay, so the identification of GIS specialist versus end users is often critical to the proper implementation of the GIS technology. So first thing is GIS specialists should be there, those who will just create the hardware of GIS and as well as the software of GIS, and later that software should be used by the end users. Okay. Now coming to the network. So what type of networking? So you have hardware, you have software, you have data, you have people. Then what we have to do with that data? So that data should be used through the networking. Like today's our data, GIS today, when we have studied in the previous lectures history of GIS and GIS today. So what the GIS today is doing, that it is helping us to network this data or to convert the information. It is helping us to communicate with the other countries and share our ideas and share our information to the different countries, so that they can just share the related information to it. So networking is a major important thing. So network allows rapid communication, sharing the digital information, and the internet has proven a very popular as well as vital for delivering GIS application. So if you have hardware, you have software, then you have data, then you have people, then you have hardware, you have software, data, people, and then later what you need is network. So what is network? Network here is internet has proven like to delivering the GIS application to the different countries or sharing our ideas through this all networking system in GIS process. So this will help us to share the information from the one place to the another place to the different countries and share our ideas to get the uh, present information, what is going on in the different worlds. So a mapping of the different cities and developmental countries, developing the area, that all information can be helpful with the help of the networking system. So network is also a major important component of GIS. So these all components together will be helpful to us to organize. So these all components will be helpful to us to organize a GIS setup. So GIS setup is not alone about hardware, it is not alone about the software, it is not alone about the data. So if you have a data and if you don't have the hardware system and if you don't have the software system, there is no use of data. So in the previous years, like long back when the GIS technology was not available, when the people was able to use only the manual digitizers or they were able to use only the paper maps. So that time the data was available but there was no hardware, there was no software. So the communication was very limited that time. So nowadays we have data as well as we have hardware and software together. So hardware and software together help us to include the data, input the data and get the final output of the data. So now if you have hardware, if you have software, if you have data, now who is using this? So like that people are required. So people are required to use this all data. So like we have Google, we have seen Google Map. So in Google Map we have two types of view. One is satellite view. Another one is map view. So these two types of data. So this satellite view is called as raster and the map view is called as vector. So this information who is viewing? People. So if people are not available, then there is no use of this kind of information which is present on the Google Map. So we have to just see that people should be there and later finally it should be used through the networking. It should be shared the information to the different countries. So the information should be shared from one country to the other country. The developmental activities should be shared from another state, one state to the other state. So whatever activities are going on in a present situation to a future situation, that all information is shared through the networking system. Okay, so these are some few references which you can go through for finding out more contents. So for everything, if you want to know about the remote sensing and GIS, you can just refer blindly this M. Anji Reddy book, which is from BS Publications, and later you can just go through this all contents to find out the more information about it. Or Tan Chang is the book from where you can just find out about the software information, and you can just get the more information about it. So it will be more helpful to you to understand more better. So that's all for today. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.